So I was given this problem in my J Advanced mock paper and I thought it was really interesting. So let's first analyze what's happening. Let me first explain what's given in the question. So these are massless rods, these two, and this is the pivot points. P and Q are pivot points, and this is a mass which will oscillate. So before we do this problem, let's first understand what's happening. To really visualize what's happening, let's first focus on this problem. This is a mass, some springs, and this is a rod with the pivot point right here. This whole thing is gonna rotate above this point like this. So what is interesting about this problem? Well, when we are given a question like this in oscillations, we first displace the mass which will oscillate, displacement of x. We give it a displacement of x, and we can clearly see that this spring will compress a distance of x. That's for sure. But this spring right here, this spring, this won't extend a distance of x. That's because of this part right here. You can try to visualize this like this. There will be a force right here, and so this rod will try to move here, and this spring will try to not make it move like that. It will provide a counter torque. So what would happen if this spring over here was placed over here, right? So that's actually pretty easy. This whole system of springs would be in series. So the question now is, what equivalent spring do we use which has the same effect as this spring but just placed over here? So if this spring had a spring constant of k, let's say, what spring constant do we need? What spring do we need to produce the same effect or the same oscillation placed over here instead of here? So if we rotate this rod or an arc length of x or an angle of theta, whatever, this spring displaces or extends a displacement of x by 2, and the extension for this is x. Now if we balance out the torques, it would be k dash x and this L, this length L, and this should be equal to the torque produced by this spring, which is k, pardon my handwriting, k x by 2, and yeah, L by 2. So coming back to the problem here, if we take this spring, place it over here, we need to reduce the spring constant by a factor of 4. This would have what? Okay. By a factor of 4. This will have the same effect as the spring placed over here. Now this is pretty easy to solve. We just take these springs as in series, and this whole problem effectively boils down to this simple problem which everyone knows how to solve. This here is k, and this is k plus I'm sorry, it's 1 by k dash 1 by k naught is equal to 1 by k plus 1 by 4 by k. So this k naught over here is this, because they are in series. Now this whole thing relates to the original problem like this. There is a spring over here. This thing is gonna rotate like this. So what equivalent spring do we use to produce the same effect as the original spring? So what values of the spring constants we use for these springs? Now we just do this thing all over again. We balance out the torques. I mean, not balance out, we equate the torques, and we find out that this k is equal to 16k, and this k dash dash is equal to 32k, and this again boils down to this simple problem. And I think that this is really interesting, that this sort of complicated looking problem just boils down to this, which everyone has done in their class at least once.